Alright, so here you see our circuit. We have two 15K resistors. The first one here goes from ground into the non-inverting input, and then the other goes from the plus 15 volts voltage source into our non-inverting input, and this one actually goes from ground into the inverting input. And then we have a couple of 5K resistors. They both come out of the output here, as you can see. One of them goes from output to the inverting input, and one of them goes from output to non-inverting input. And then down here we have a variable resistor, which will vary from 3 to 12K, and see where the current, which should ideally be 1 milliamp, starts to drop off. Alright, so here you can see when we have it hooked up to a 5K resistor, the current is at 1 milliamp, which is ideal current for this circuit. And as we move to 7.5K, as we thought, it's not up to 10 or 12, so it's also at 1 milliamp for the current. Now when we go up to 12K, it's actually going to drop off and look like 0.9 milliamps. So the current's starting to drop around 12K resistor, and at a 15K it's dropped all the way to 0.7 milliamps, which is what we had predicted. And when we put a short in, we just stick a wire instead of the resistor, and it looks like it's actually still at 1 milliamp, so holding strong at the ideal current. And now when we put a Zener diode in, which is actually reversed here, at 0.82 milliamps is the current, so it looks like it couldn't sustain 1 milliamp, and the voltage at which it started to drop off for that reverse diode is 3.74 as we measured the voltage across it. So now let's have a look at the PSpice simulation and see what that can tell us.
This is the circuit that we set up for our current source. This resistor here sweeps from 5K to 15K. This is a simulation of that circuit. You can see that 5K through about 9K, it stays pretty constant at 1 milliamp. Even 10K is pretty close. But as you get to 11, 12, 13, 14, 15, it starts dropping. So 11K is about the limit. This is our circuit set up with the Zener diode. It lets the current flow through it pretty freely. Here's the simulation for that circuit, and after some initial instability, it steadies out pretty close to 1 milliamp, which is the ideal value that we would want. In this circuit, we just flip the Zener diode around. Here's the simulation for the Zener diode in reverse. And you can see that there's some initial instability again, but eventually it levels out at about 1 milliamp, which is the ideal value that we were looking for. This is a simulation of the same circuit, but this time we measured the voltage across the Zener diode. And we can see that the breakdown voltage for that particular diode is 4.425 volts.